Okay, so here on the next page, here we have an ASA triangle, right? Because they tell you that angle A is 48 degrees, angle B is 63 degrees, side C is 9.7, right? So I know two angles and then the side in between the two angles. So to figure out angle C again, it's similar to before, right? Because I know two of the angles, so I can calculate it by with the rule that all three should add up to 180, right? So angle C would just be 180 minus 48 minus 63. So 180 minus 48 minus 63. So we get 69 degrees for C. So this is 69 degrees, and then trying to figure out side A and side B. It's the same as before, right? So now we use the law of sines, right? So angle C and side C is the one that's completely known, right? So say if I want to figure out A, I should relate it to C. So plugging in the information, what do we get? So A over sine 48 is equal to 9.7 over sine 69. So what does this mean? So A is equal to, so I need to multiply the sine 48 over, right? So it's 9.7 times sine 48 over sine 69 degrees. So what do we get for A? So 9.7 times sine 48 divided by sine 69. So we get about 7.7. Okay, so A is 7.7. And then what about side B? So we can do the same thing, right? So B over sine B, we relate it to C. So it's equal to 9.7 over sine 69 degrees. So let's calculate this. So the calculation is basically similar, right? So I need to multiply sine B over, which is 63 degrees, right? So B is equal to 9.7 times sine 63 degrees over sine 69 degrees. So what do we get for B? We get about 9.26, about 9.3. Okay, so we get side B is equal to 9.3. So one thing you can remember to make sure at least the calculations are on the right track is that the bigger the angle, the bigger the side is going to be, right? So you see how in this triangle, C is the biggest, angle C is the biggest, and then next is angle B, and then angle A is the smallest, right? So then comparing the three sides, it should be the same, right? So you see how side C is the biggest, and then comes side B is next, and then side A is the smallest, right? So so the angles and the sides should relate to each other in this way, where the bigger the angle, the longer the corresponding side. Okay. So those are the situations where you know two angles and a side. So that's sort of the easy case for the law of sines, right? So the other situation is the SSA triangle, where we said there could be one, two, or no solutions. So let's see what happens. Right, so how do we deal with the SSA triangles? Right. So there's a few things you want to remember, right? So again, for a triangle, all angles should add up to 180 degrees, and the sine function should always give values between -1 and 1, including -1 and 1. And so the reason that this is important is because if you get something where the sine function has a value bigger than 1, then that means that that's impossible, right? So that's the case where you have no solution. And the other thing to remember is that when sine is positive, so if you remember the four quadrants, right? So all students take calculus. So sine is positive in both the first quadrant and the second quadrant. And so when sine is positive, the angle can be either acute or obtuse, right? So the angle could either be between 0 and 90 or between 90 and 180. And this is the situation where there's possibly two solutions. Okay, so so from this, what you want to remember is that for an SSA triangle, if the given angle here is obtuse, then you're okay. You can just solve it exactly as we've done previously. But if the given angle is acute, that's the situation where there could be 0, 1, or 2 solutions, right? So the case where, as I said before, the case where there's no solution is when you get a sine value that's bigger than 1, right? So that's impossible, so there's no solution. And in the situation where the sine angle is smaller than 1, what you want to do is determine both theta and 180 minus theta, right? So again, the reason we do that is because the angle could either be between 0 and 90 or be between 90 and 180. So you have to check both possibilities. And then once you calculate these two possibilities, you want to check if the obtuse angle is possible or not, right? So you can check it by from the fact again that all angles in a triangle should add up to 180 degrees. If you get something where that doesn't happen, then only theta is a solution, right? So that's one solution. But if the obtuse angle is possible, then these two are both solutions. So either the acute or the obtuse. Okay. So that's the situation with SSA, right? So let's look at these different possibilities.